Okay, now that we know he's going the distance, let's figure out how far that is. So what we're going to do is determine the distance or the length of a line segment that connects 2 points, like I have drawn here, the point 25 and -4, -2. Now to do that, we're going to use the distance formula. And the distance formula states that the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, and now we're going to use this formula. Where does this formula come from? Well, you'll probably be happy to know that I'm not going to derive it in this video. I'll leave that up to you for fun later, said the math teacher only. But if we look at our picture here and we actually look at what we can make out of any line segment, all right, you will start to get an idea of where the formula comes from. So notice that if I connect this and make a right angle, I've now got a right triangle. And how do we find the length of the hypotenuse of a right triangle? Well, it's this length squared plus this length squared equals this squared. And now you can start to see where the actual formula comes from. All right, so instead of having a square, we have the square root, and this is the one side squared plus the other side squared. All right, so in your spare time, looking for something to do, you can always do that. All right, so what we're going to do, these are my points here, 2, 5, and -4, -2. We're going to plug them into our distance formula and find the distance. Okay, now what I like to do is label my points. I think of points as a pair, and the number is their last name, just like a couple when they get married take the same last name. My points, when they go together, they have the same last name. So this 1 and this 1 means that they go together. So I'm going to label this x1, y1. Okay, and now this 2 and 2 means that they go together, so I'm going to label this x2, y2. And now I find that if we label our points, we made less errors, and now we can just plug into this formula. So its distance is going to be the square root of x1, which is 2, minus my x2, which is -4. And now don't forget, you've got to square that whole thing. And to that, we're going to add y1, which is 5, minus my y2, which is a -2, and then we're going to square that. And now probably the trickiest part that most of my students find is that we want to get ahead. We're not going to square until we do the math in parentheses, okay? And the other thing is, remember what happens when we minus a minus, right? 2 wrongs make a right in math class, and math class only. So we end up here with 2 plus 4, which ends up being 6, and now don't forget I haven't squared that yet. And in here we end up with 5 minus a -2, which ends up being 5 plus 2, which is a 7, and now we need to square that. So now for my distance formula, we know that 6 squared is 36, 7 squared is 49, okay. So now I'm going to add those together. 36 and 49 gives me 85, still taking the square root. And now at this point, I can see if I can simplify that. This I can't, because this is the product of 5 and 17. But what I may want to do is actually come up with a decimal equivalent. So using my calculator, I'm just going to take the square root of 85. And I see that this is approximately 9.22. Well, why is that important? Well, if he's going the distance, he's going to want to know what that distance is, okay? So what this is telling me is that the distance from here to here, okay, or in other words, the length of this line segment is 9.22. And now that could be meters, it could be miles, all right, could be inches, but that's what the formula is telling me, okay? Now, we also want to talk about the midpoint, and when we talk about the midpoint, if he's going the distance, he might want to know where is the midpoint, and he wants to take a break there. Now, just eyeing this out, I'd say that the midpoint is probably somewhere around here, okay? And that would be halfway. In other words, where he went, what, half of 9.22, approximately 4.6 if this is miles or whatever. And now we have a formula for midpoint as well. The important thing to remember about midpoint is that it is a point. And what we know about points is that they will have both an x and a y coordinate. Now also think about, how do we find the middle of something? Well, you've been doing this for years. You find the middle of numbers by just taking their average. And since we have two x values and two y values, we're just going to take the average of the x's to get our x coordinate and take the average of the y's to get our y coordinate. How do we take an average? When we only have two things, we add them together, divide by 2. So to get the x coordinate, we're just going to add the x's together, divide by 2. To get the y, we're going to add the y's together, divide by 2. Once again, if it's easier, you can just label these x1, y1, x2, y2, and from there we're just going to plug in. So my x coordinate is going to be 2 plus a negative 4 divided by 2. And my y coordinate is just going to be 5 plus a negative 2 divided by 2. Now notice here we were adding, whereas before in the distance formula we were subtracting. All right, and this is just my comma to show that this is one point, that's the other. All right, so 2 minus 4 is a negative 2 over 2. And 5 minus 2 is a 3 over 2. And now simplifying this, negative 2 over 2 becomes negative 1. And this is just 3 over 2. Or if you are a decimal lover, it's negative 1, 1.5. Okay? And so now if I go back to my graph, what have we found? Negative 1, 1.5. So if I come back here, negative 1, 1.5, voila. I see that right here. When I eyed it, I was pretty darn close, is my midpoint. So if he's going the distance, 9.22, he would stop right here to take a break if he was stopping at halfway. All right? All right, just to make sure that we've all got it, let's do one more example. Okay? All right, in this example, we've changed the point slightly, same idea. We're finding the distance, we're finding the midpoint. All right? So looking at our formulas again on one page, and here are my points. Again, it is a good habit to label your points, x1, y1, x2, y2, and if you do that, then your formulas become easier to use. All right, so for my distance, I'm going to have the square root of x1, which is negative 4, minus x2, minus a minus 1, and then don't forget that entire thing needs to be squared. I'm going to add to that y1 minus y2. Right? Don't forget that needs to be squared. All right, utilizing my formula here. All right, what's going to happen in here? Well, we get minus and minus again. So negative 4, sorry, plus 1 is going to be negative 3. And then we're going to square that. And then negative 5 minus 7 is a negative 12, and then that gets squared. You can notice that if we forget to square, we're going to end up with negative numbers. Two things here. We can't really have a negative distance, so that would be your first clue you've done something wrong. And the only way we can take the square root of a negative number is to deal with the imaginary unit, which really is hard to get our head around when we're talking about distance. So now we're going to square these. Negative 3 squared is 9. Negative 12 squared is positive 144. So our distance is going to be 9 plus 144, the square root of that, which is the square root of 153. Now, again, you can see if that would reduce. This does not, or simplify, because this is the product of 3 and 51. Which are prime numbers, nothing would come out of the radical. But what we can do is take the square root of that and get a decimal approximation, and this tells me 12.37. Okay, so again, we don't know our units. We haven't really done that. He's going the distance, and now we know what that distance is, and that's going to be the distance from here to here is going to be 12.37. Okay, well, that's even longer, so it makes sense that he may want to stop at the midpoint, okay, and take a break. So let's look at our second example here, the midpoint, or our second formula. All right. And again, we're just going to use that formula, okay, to find the midpoint of these two, of the line segment that connects these 2 points. All right. So for this, I'm going to take x1 plus x2. So we get negative 4, sorry, plus -1 divided by 2. And I'm going to take y1 plus y2 divided by 2. So this is going to be -5 plus 7 divided by 2. Okay. All right, so here we have -4 plus -1. That gives me -5/2. That's going to be my x-coordinate. And here I get -5 plus 7 is a +2, 2/2. Simplifying that. This does not simplify, well, it's -2.5. So for my decimal loving friends, we can write -2.5 and then 1. So now we can always go to our graph and check that and see, is -2.5, 1, the midpoint, -2.5, and then up to 1, that's going to be right here. And eyeballing it, it does look to be about halfway. So this is our midpoint. All right. All right. So I hope that you've enjoyed this video, and now when he's going the distance, you can tell him how far he's going, and you can also tell him where the midpoint is.
He's going the distance.